Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is increasing and decreasing function. So here is the definition of increasing and decreasing function. We all know that if something is increasing, then it is going up. And if it is decreasing, it is going down. Another way of saying that a graph is going up is its slope is positive. If a graph is going down, then we can say that the slope will be negative. Since slope and derivatives are synonymous, we can relate increasing function and decreasing function with the derivative of the function. So let me give you the formal definition of increasing and decreasing function now. A function is said to be increasing on an interval if for any 2 points x1 and x2 in that interval, then x1 is less than x2, which implies f of x1 is less than f of x2. So this is the definition for increasing function. Now let us move on to the formal definition of decreasing function. A function will be considered as a decreasing function on an interval if any 2 points x1 and x2 in that interval, then x1 is less than x2 implies f of x1 greater than f of x2. Hope you are clear with these formal definitions of increasing and decreasing functions. Okay, now let us see how does this relate to derivatives. For this, we have to recall the derivative is the limit. We know that f of x2 minus f of x1 over x2 minus x1. So consider this definition. If f of x1 is less than f of x2, you can just take the point x1 is less than x2, then the denominator will become positive. Am I right? If also f of x1 is less than f of x2, the numerator will become positive. Hence, the derivative will be positive. On the other hand, if f of x1 is greater than f of x2, then the numerator will become negative. Am I right? Then the entire derivative will become negative. Thus, this leads to some theorems. Let me list all those theorems. Those theorems will be helpful in testing whether the function is increasing or decreasing. Consider a function f. Consider that f be a differentiable function on the interval a comma b. Then, first theorem says that if the first derivative is negative less than 0 for x in the interval a comma b, then f is decreasing there. If the first derivative is greater than 0, I mean the first derivative is positive for x in the interval a comma b, then the function f is increasing there. Okay, so what will happen if the first derivative is equal to 0 in the interval a comma b? Then the function f would be considered as constant. Hope you are clear with these three theorems. Okay, now let us discuss few examples and check how to find the increasing and decreasing functions. These are the steps for finding the increasing and decreasing functions. So step 1, locate the critical numbers in domain for the function f, and then you have to determine a set of open interval with the critical numbers and endpoints. I mean the points that you're getting in this step. Step 2 is for each open interval pick a point x, and you have to replace that x value in the first derivative f dash, and then you have to find what value you're getting. You have to check whether it is a positive, negative or 0. After finding this, you have to classify each interval as increasing or decreasing for f. You can use the sign test. So these are the 3 steps. Let us see an example. Here is an example. We are given a function. We are supposed to find where the derivative is positive and where it is negative, and also we have to find the roots. Okay. So in this question we have f of x is equal to 2x cube plus 3x square minus 12x plus 7. First, let us take the derivative f dash of x. F dash of x is 6x square plus 6x minus 12. Derivative of the constant would turn into 0. Hope you all know that formula. Okay, in case if you have any query regarding finding the derivatives or its formula, you can refer our previous videos. Okay, to determine where the derivative is positive and where the derivative is negative, we have to find the roots here. So I'm going to factor this. Hope you can notice that 6 is the common factor for all the 3 terms. So I'm taking it out first. Now you can factorize this expression. So 2 numbers would be negative 1 and 2. So if we set first derivative equal to 0 and solve for x, we will get x is equal to 1 and x is equal to negative 2. Now let me create some test values. I'm going to take some values. Just plot these 2 points on the number line and pick the numbers in between. That would be a good idea. So I'm going to take negative 3 left to negative 2 and 0 in between and I'm going to take a positive number after 1. So let me take 2. Just take the numbers on either side of the critical numbers. Okay, let me give you the values. Better I make a table. All we are going to do is just plug in these points in the function f dash of x, and you have to find the corresponding value. So if I replace x by negative 3 in this f dash of x, I'm getting 24. Hope you're getting the same value. Same way, if I replace x by 0 in f dash of x, I'm getting negative 12. And then plug in the next value 2 in f dash of x. So after plugging in this, I'm getting a positive number again, positive 24. We just found f dash of x, set that equal to 0 and solve for x. After that, we are finding the numbers on either side of x values. And then we are plugging in those values in f dash of x to find the corresponding values, so that we can easily check whether it is a positive, negative or 0. The derivative is positive outside negative 1. Am I right? And it is negative inside negative 2 to 1. So we can conclude that the function f is increasing outside of negative 2 to 1 and increasing inside of negative 2 to 1. So the graph will be, let me post the graph. Here is the graph. We saw that the values of x such that the derivative is 0 was of special interest. Other points where there could be a change from increasing to decreasing is where the derivative is undefined. So we call c a critical number if either f dash of c is equal to 0 or f dash of c is undefined. So if these are the two conditions, you can say that c is a critical number. Hope you're clear with this example. Let us discuss one more example. Here is the next example. We are supposed to determine the intervals in which the following function is increasing or decreasing. Okay, here is the function x cube over 3 plus x square over 2 minus 6x plus 5. So we can rewrite this before differentiating. Let's take the derivative now. So this would become x square, 3 gets cancelled out and 2 gets cancelled out. So f dash of x would be, hope you're clear with this step. Now set f dash of x is equal to 0. And then factor the expression on the right side. So by factoring we'll get, so if you solve the factor, you will get x is equal to negative 3 or 2. So our critical values are negative 3 and 2. So our intervals would be negative infinity to 3, negative 3, negative 3 to 2, 2 to positive infinity. Now let's test these intervals to see if they are increasing or decreasing. So we know that f dash of x is x square plus x minus 6. I'm going to pick some number in between. Any number in between this, negative infinity to negative 3. Let me take negative 4 and plug in that point in f dash of x and check whether we are getting a positive or negative number. So if I plug in negative 4 in this first derivative, I'm getting 6, a positive number. If f dash is positive, then we can say that the function is increasing in this interval. Am I right? Same way, let us pick one number in this interval, negative 3 to 2. It can be any number. I'm going to take 0 because that would be easy for calculation. So replace x by 0 in the first derivative. So we will get negative 6, a number lesser than 0. So if the first derivative is negative, then we can say that the function f of x is decreasing. Now let's check the next interval, 2 to infinity. Let us pick any number. I'm going to pick x is equal to 3. Replace x by 3 in f dash of x. So we will get which is equal to 6. A positive number. It means f of x is increasing in this interval, 2 to infinity. Either you can make a table and give the results, or you can directly show all your steps like this. This is just for your information. You can make your work simpler by reducing the work. You can always give your values in a table format. It will be very clear. So this function is increasing in negative infinity to negative 3, and the function is decreasing in this interval negative 3 to 2, and the function is again increasing in the interval 2 to infinity. Hope you are clear with this example. So take the derivative of the function, find the critical values. I mean solve for f dash of x is equal to 0. So these will give us our intervals. Now choose a value that lies in each of those intervals and plug them into the derivative. If the value is positive, then the interval is increasing. If the value is negative, then the interval is decreasing. So this is all about increasing and decreasing functions. In case if you have any query regarding this topic, kindly let me know. You can form your own example and check whether the function is increasing and decreasing in any particular interval. And let me know in the comment section. See you in the next video.